So as we have established, connective tissue comes in many forms and many types. These different types and subtypes can be classified based on the connective tissue cells present, as well as the amount and distribution of ground substance and protein fibres. In the coming slides, we will discuss the makeup of each connective tissue type and subtype, and how this makeup contributes to its function. So taking a broad look at connective tissue, and connective tissue can be classified into two general types. Connective tissue proper, which is further divided into loose and dense connective tissue, depending on the ratio of ground substance to protein fibres. And specialised connective tissue, which is further divided into cartilage, bone, and blood, and which each contain a specialised connective tissue which is specific to that type of connective tissue only. But coming back to look at each of those types individually, and first looking at loose connective tissue, and the fibres of loose connective tissue are loosely arranged between cells. In other words, there is a high proportion of ground substance with relatively fewer protein fibres arranged in between it. There are three subtypes of loose connective tissue. These are areolar connective tissue, adipose tissue, and reticular connective tissue. And although each have that loose arrangement of fibres within the ground substance, they are all structured slightly differently. So looking at each of the loose connective tissue subtypes, an areolar tissue is one of the most widely distributed connective tissues. It consists of collagen, elastic, and reticular fibres, arranged in a random pattern around several kinds of cells, including fibroblasts, macrophages, plasma cells, adipocytes, mast cells, and a few white blood cells, all embedded in a semi-fluid ground substance. Areolar tissue is found in and around nearly every body structure, and that's why it's sometimes called the packaging material of the body. It can also be found in the layer of tissue deep to the skin and around blood vessels, nerves, and organs. The function of areolar tissue is to provide support, strength, and elasticity to the structures. Adipose tissue contains cells called adipocytes, or fat cells, which are specialised connective tissue cells for the storage of triglycerides or fat. With weight gain, a fat cell will fill up with a single large triglyceride droplet. In adults, most of our adipose tissue is white. This is the adipose tissue that contains one single triglyceride droplet per cell, and it functions to serve as an energy store and for insulation and protection of different organs and joints. Acts a little bit like a cushion. In babies and infants, and in very small amounts in adults, we have brown adipose tissue. This adipose tissue contains many triglyceride droplets per cell. It's also highly vascularized, so it has lots of blood vessels, which is what gives it its brown colour. It also contains many mitochondria, which help serve its major purpose, which is to generate heat, which happens as a byproduct of producing energy. Reticular connective tissue is a fine interlacing network of reticular fibres and reticular cells. Our reticular cells are the specific type of fibroblast that produces reticular fibres. Reticular connective tissue forms the supporting framework of soft organs such as the liver, spleen, and lymph nodes, as well as the basement membrane, which is like the bottom layer of epithelial tissue, and also layers surrounding blood vessels and muscles. So taking a look at those connective tissue subtypes, and we have our areolar tissue on the left, so with our thick collagen fibers, some thinner, branching, elastic and reticular fibers. We have our adipose tissue in the middle here. So you can see this is a white adipose tissue. This is one adipocyte or fat cell, which fills up with triglycerides or fat with the increasing need to store energy. And then we have our reticular connective tissue on the right. So these dark bits here are our reticular fibers. The purpley bluish dots are our reticular cells, which is what produces these reticular fibers. Now, with all of these images, don't freak out that I'm going to provide you with a microscope and some slides and ask you to identify any of these particular subtypes. I definitely won't be doing that. I just wanted you to see what these tissues look like, because then otherwise all of this information is just words. So coming back to this figure, and the other type of connective tissue proper that's found within the human body is dense connective tissue. And dense connective tissue contains more fibers than loose connective tissue, and they're more closely packed together with less ground substance in between. Within dense connective tissue, we also have 3 subtypes. These are regular connective tissue, irregular connective tissue, and elastic tissue. So looking at those subtypes, and dense regular connective tissue forms a shiny white extracellular matrix made up mostly of collagen fibers arranged regularly or in parallel in bundles, so nice and neatly or lined up next to one another. This arrangement of mostly collagen fibers forms our tendons, our ligaments, and our aponeuroses, which are like sheet-like tendons that attach either muscle to muscle or muscle to bone. Our regular connective tissue provides strong attachment between various structures. And although this tissue is very strong when pulling along the line of the collagen fibers, it can be prone to breakage when the line of force or the tension comes in from another angle. Our dense, irregular connective tissue is also made up of primarily collagen fibers, but this time arranged in an irregular fashion. It's often found in sheets, such as the fascia or the tissue beneath the skin and around muscles, surrounding the heart and surrounding the outer layer of bone. Also, like dense regular connective tissue, our irregular connective tissue provides strength to the tissue. However, because of that irregular arrangement of the fibers, so they're not all only in one line, it can actually provide strength in many directions, which is important for structures like our skin, our heart, bone, or gastrointestinal tract, which can be pulled in all directions. Our elastic connective tissue, as you would expect, is made up mostly of elastic fibers. For this reason, elastic tissue is found within lung tissue, bronchioles, vocal cords, and blood vessels. Elastic connective tissue allows organs to stretch, but more importantly, to recoil and to return to its original shape after being stretched. So again, taking a look at what these tissues actually look like. And on the left, we have our regular connective tissue. So you can really clearly see those large numbers of collagen fibers that are all arranged in nice, neat, parallel lines. This tissue in the middle is our irregular connective tissue. So kind of looks the same, but those lines are not all nice and neat. The collagen fibers are all arranged all over the place. And then the tissue on the right is our elastic tissue, which is full of elastic fibers. And you can see quite clearly here that this wavy structure will allow that tissue to stretch, but then also recoil. We then move on to our specialised connective tissue. And the first type of specialised connective tissue is cartilage. And cartilage consists of a dense network of collagen and elastic fibres, firmly embedded in a gel-like ground substance. Cartilage can endure more stress than loose and dense connective tissue, with its strength attributed to the high proportion of collagen fibres and its resilience, or its ability to bounce back after it's been compressed, due to that gel-like consistency of the ground substance. Now, cartilage differs slightly from other connective tissues in that it has a very low or very poor blood supply. And for that reason, the ability of cartilage to heal after it's damaged is quite low and quite slow. So the first subtype of cartilage is elastic cartilage. And elastic cartilage is made up of chondrocytes, so our cartilage cells, within a thread-like network of elastic protein fibres. Elastic cartilage is found in your epiglottis, which is that flap of cartilage which covers your trachea or your windpipe when you swallow, as well as the external part of your ear, so the bit that you can kind of feel on the side of your head, and the tubes that then lead into your brain, into your skull. Elastic cartilage provides strength, but also a high degree of elasticity to a structure. And so it helps maintain the shape of certain structures that are non-weight bearing. Hyaline cartilage is made up of fine collagen fibres, prominent chondrocytes, and a resilient gel-like ground substance. It appears bluey white and really shiny within the body. And it's actually the most abundant cartilage. So this is the greatest type of cartilage within the body. Hyaline cartilage is found at the end of a long bone, the external portion of your nose, the bronchi and bronchioles within your lungs, and then also the embryonic or the fetal skeleton. So at the ends of long bones, hyaline cartilage provides a really smooth surface for your joints so that your bones don't rub up against each other when we move. It provides flexibility and support in the nose, the bronchi, and the embryonic skeleton until that skeleton is then calcified and becomes hard. However, this type of cartilage is the weakest type of cartilage, and it can actually be fractured if it's exposed to trauma. Lastly, we have fibrocartilage, which is made up of chondrocytes among really thick bundles of collagen fibres. Fibrocartilage is found in regions that bear weight. So this could be the pubic symphysis, which is where your two hip bones meet at the front. The intervertebral discs, which sit in between the vertebrae in our spine. And the meniscus, which is that pad of cartilage in the knee, which sits between the femur and the tibia. Fibrocartilage supports and joins structures together, and its strength and rigidity, mainly due to those thick bundles of collagen fibres, make it the strongest type of cartilage. Once again, taking a look at those subtypes of cartilage, and on the left here we have our hyaline cartilage with that gel-like ground substance and then the prominent chondrocytes. There aren't as many cells or fibres in this type of cartilage, so it can be quite thin, like at the end of a long bone. This middle image is our fibrocartilage, so you can see all those long lines of collagen that's nice and densely packed in together, so it gives us a nice amount of strength. On the right, we have our elastic cartilage, and all of these dark purple lines are our elastic fibres surrounding those white bits, which are our chondrocytes. Our next type of specialised connective tissue is bone. And I'm not going to go into too much detail about bone because the skeletal system and bone tissue will be the focus of the next series of modules and recordings. However, bone has two subtypes: compact bone and spongy bone. So bone tissue supports soft tissues, it protects delicate structures, and it works with skeletal muscle to generate movement. Bone stores calcium and phosphorus. It houses red bone marrow, which produces blood cells. And it contains yellow bone marrow, which is a storage site for triglycerides or for fat. Bone tissue can be classified as either compact or spongy, with compact bone being made up of osteons, which are these circular structures here, which all form in quite close proximity to one another to form quite a compact and dense looking bone. It sits on the outside of all of our bones. Spongy bone is made up of trabeculae, which is this kind of like branching network of bone here. There's more space between the branches of trabeculae, which makes the bone more flexible and light. But red bone marrow forms within these spaces, which is where our blood cells are produced. Both types of bone tissue are made up primarily of collagen fibres, which give it its strength. The ground substance of bone tissue is also mineralised or calcified, which adds to its hardness. Finally, the last type of specialised connective tissue is blood. And again, like bone, I'm not going to cover blood in too much detail as it's covered in blood and the cardiovascular system in a number of other units. However, blood is a special type of liquid connective tissue which has a liquid extracellular matrix. This liquid extracellular matrix is made up of blood plasma. Suspended in the blood plasma are formed elements, so namely red blood cells, white blood cells, and platelets. So we have our red blood cells here, our white blood cells, and our platelets. Blood is the only type of connective tissue which does not contain any fibres.